Alright, so I haven't made any videos in a while. This is the antenna project so far. This is the new stuff that I haven't shown yet. This dipole antenna is an interesting antenna. I got it from DX Engineering. If I get a chance, I'll leave a link to it in the comment section. But we did modify it, so this is not the factory way. All this is the normal what you would get with it. I'm just making sure I got this. It was really cold out here the day that I was kind of gooping this. This is a direct feed, so I was kind of gooping this stuff over the direct feed to kind of insulate it from moisture and stuff. But man, when your hands start going cold and stuff, it's really hard to do stuff. But you can see it's a pretty basic rotatable dipole with insulating blocks. Hot on one side, ground on the other. But I'll show you guys what we did. So the original setup here is kind of, I would say, a little not so great in the sense because we're only using like machine screws that don't go all the way through. So they basically just screw in, and there's only one. There's one that was here. So what we did, me and a good friend of mine, who goes by Grease Monkey on the CB, we drilled through. So now you can see on this side, you're definitely got a strong connection here. Now this was wobbling and stuff. It was really not a good ideal setup how they did it. So also we did another one here. What we ended up doing is switching the tube. This is off an old Cushcraft 10-meter beam that I still have parts to. This is a Cushcraft tube. You can see the difference in the tube. This is much longer than what we needed. But what ended up happening was with the stock tube that they gave you was to make it even anywhere close to being in resonance on 11 meter, you had little to nothing. And all you had here was a hose clamp. There was no screw because this was meant to be adjusted. So it was really not a good setup. So we've made this thing bulletproof now. It's a real antenna now in the sense that it will not suffer wind breakage or anything like that. The antenna says it's designed for 10 or 11. Now maybe in the 10-meter configuration you can probably get away with the stock configuration, but I don't know. If you go up to your antenna and go like this and the elements are like shaking and vibrating and stuff, it's usually not a good sign. So we've definitely made this stronger. This is where the adjustment point is now. So this is the factory tube again. This is what I mean here. We left that screw alone because this is a very narrow tube, and it's very strong with that screw. I might actually screw that a little tighter if I can, but this isn't going anywhere. So we replaced this with a much longer tube, which allows now this to slide in a little deeper as far as that goes to make adjustments. So obviously it's the same on both sides. I got my glove in the way, sorry. So there's that. What else do we have go? Let's go over here to the analyzer and see what it's looking like. So it's looking really good. I wanted this for CB, and that's ideally what I got there. So I'm really happy with that. I guess this is an all parameters have come up here. That's like a little over channel 40, and there's channel 1 somewhere down there. So it's really good. Let's go to the SWR chart. I can put this in 1000 kilohertz. Let's see where our dip is. So our dip's at about channel 26, and that's good enough for me. You can see the 2 to 2 mark is probably where about that's 1.5 still. So where's 2? A 2 SWR was somewhere. It's going to be up in 10 meters, so this won't cover both bands, and that's fine. I didn't want it to do that. I have the Mosley for 10 meter anyway, so there's no problem there. So yeah, even at 28.525, I guess it's under a 2 to 1. So where's it going to go to 2 at? 28.905. So it's pretty broad banded, which you would expect from a dipole, basically like a half wave dipole. You can see where it starts to climb back up on the lower end too. Now again, this isn't what you're going to find from the factory on this antenna. It wasn't this broad banded, and it was just kind of very cheaply made, I guess we could say. So that's that antenna. Obviously we have the SolarCon Max 2000 optimizer here. This, we modified the bracket. This is like a bulletproof design that he did for me. So actually I want to try to tighten that one a little bit more if I can, but it's got these bolts, and we got 2-inch clamps because I'm gonna have a 2-inch pipe for the antenna. We did adjust the antenna a little bit. The rings are towards the top, but it's perfectly in resonance for the CB band. And again, that's where I want it. This is for local general CB usage, that kind of thing. So I'm just going to take my nut and my bolt and kind of try to tighten that a little bit more. You can see he didn't fully tighten these because we're going to be taking this off tomorrow. And that's probably why he didn't do it. So yeah, I'm just going to leave that alone because this is coming off here. This is all just temporary, but see, that is some heavy duty work there. This is not going to falter up on top of a tower on a 2-inch pipe. So this was an angle iron that we cut in half, and then we've screwed into this. So basically it's double protected. So it's definitely not going to break. Now this antenna is quite interesting, and I want to double check this because I'm going to switch the feed line on it. This is a Mako balcony antenna. It's a 6-meter antenna, so this is not for CB band, this is for 6 meter. So you can see it's physically a lot shorter than the 11-meter behind it. And I'm wondering quite possibly if when I'm transmitting on the 11-meter dipole, I don't know if it's going to really matter, but we were both kind of wondering if it may see that as some type of director, even though it's not for the right frequency. And we're wondering maybe if when the 6-meter is being used, if it would see the 11-meter somewhat as a reflector. Don't really know. It could make them a little more directional than just a standard rotary dipole. It could be interesting. But this is ideally what it's going to be when it's on the top of that, which we want to get about a 15-foot pipe coming out of the top of that, which would give us 64 to the top of the tower and then 15 foot more. And with these on top of that, so 79 feet up for both of those and the SolarCon. So that's going to be a long ways up in the air. In the between, I don't know if I showed this or not. I have the 2M9X there. At the very bottom of the tower, the Mosley TA53 mic. And also I have a 13B2 Cushcraft that I think I'm going to put up there instead of the little vertical stack. Probably just have that taken down and get the gain from the 13B2. I know that there's some mass pipe interference due to a vertical beam with the mass pipe going right through it, but I think the gain of the Cushcraft 13B2 should probably outweigh. I don't know if I'm going to do that yet or not, to be honest, because I don't know, I really like that little beam, and that thing is bulletproof. So I may honestly just keep that the way it is, and just put that up there. I don't know. It's one of those things where, should I use the 13B2? It's very old, it's used. Only thing I worry about is that matching box on it, if that were to start letting in moisture or something. And I did silicone it and seal it and stuff, but you just never know with those, especially when they get old and they get ratty from being in the elements too long. This antenna doesn't have any really matching network. What it has is the 75 ohm power divider, but that's inside the phasing boom. So it's basically bulletproof. So I may just actually go with that and say the heck with the 13B2. But that's what we got going on so far. Let's take a quick peek at the 6-meter Mako, because I want to possibly adjust that a little bit more if I have to.